This is lesson 3.5, solving quadratics by factoring. So we're talking about solving quadratic equations like we talked about. Quadratic equations look like a parabola on the graph, and the points or point at which that parabola hits the x-axis, those would be the solutions. So this is, using our knowledge of factoring, we can solve for p. Now that our equation is set equal to 0. Previously in Unit 2, we were just looking at expressions and practicing factoring. So you'll see how that applies here. So we'll factor in the same way that we did in Unit 2, starting with a negative. First of all, noticing what our A value is. Here's a 1, B is negative 2, C is negative 15. And since A equals 1, we have our simplest method of factoring, and we just put our C value on the left side of the t-chart and the negative 2 on the right side. That's our B value. And try and find the two values that multiply to get negative 15 and add to get negative 2. So that works out to be negative 5 and 3. And we can rewrite this in factored form now. P minus 5, P plus 3 equals 0. So this is the new part. Now we're applying the zero product property, which means, so here is the zero product property, and this is not new. That says that anything times 0 is 0. Anything, any value times 0 equals 0. And so, in this case, since this thing here, p minus 5, times this thing here equals 0, that p minus 5 has to equal 0, or p plus 3 has to equal 0. So we set those both equal to 0 and solve. So here it's fairly simple. P equals 5 here as well. We just subtract 3 from both sides, so p equals negative 3. So my two solutions would be 5 and negative 3. So these on the front page, your first step here, which was already done for us, is to get the equation. This is step number 1. We'll scratch out number 2. You're not responsible for doing that one. Get the equation into standard form. Remember, that is ax squared plus bx plus c equals 0. So it's important that there is a 0 after the equal sign. Number 3 is already in that format, so step number 2 would be to factor. So we've got the 16 goes on the left side, that's our c value, and the 8 goes on the right side, that's our b value. Two numbers that multiply to get 16, add to get 8, would be 4 times 4. In fact, I could have recognized this as a perfect square trinomial. My first term is a perfect square, my last term is a perfect square. It stands out. When these two are the same, you know you've got a perfect square trinomial as long as a is 1. So I could write this as m plus 4 equals 0, or I could actually write this as m plus 4 squared equals 0. Now, to solve, if we had the squared here, we would just square root both sides. Square root of 0 is 0, though, so then we just wind up with m plus 4 equals 0. Subtract 4 from both sides, m equals negative 4. Now, this is one of those cases where there is just one solution. Right? We talked in your lesson 3.4 that you can have one solution, so in this case, or you could have two solutions where it hits the x-axis in 2 spots, or the other option would be to have no solutions. So let's take a look at a problem where we have to set it equal to 0. In this case, we need the 12r on the left-hand side, so we add 12r to both sides. We get r squared plus 12r plus 35 equals 0, and factor from here.
We lost track of time.
I'm out on Tuesday, so I need to get my
Yeah.
stuff ready.
All right.
Thank you. So our, let's see, now that we have it in standard form, the 35 goes here, the 12 goes here, and we have two numbers that multiply to get 35 and add to get 12 are 7 and 5. And now that it's equal to 0, we apply the zero product property. So r plus 7 equals 0, r plus 5 equals 0, and solve each one. So r equals -7, r equals, subtract 5 from both sides, -5.
My ride's here. Love you.
Love you, see ya. You're on video.
What do you mean? I'm sorry.
That's okay, so is Patrick.
Y equals mx times b.
Thanks, Crystal DeYoung. Don't listen to her. See ya.
So, Chris, I was hoping you weren't talking to this. You're going somewhere this weekend?
Yes.
Enjoy.
I'll just
Have fun.